Hi, everybody. Glad you could come. Um, I'm Will, and I am the conservation chair of the at the Lower Columbia Canoe Club. And I'm also really interested in this topic tonight. So was very happy when Adam I'm sorry, when Adam Stonewall wanted Adam, I'm sorry, I blanked out on your last name. But Adam Stonewall is with us, and I'm very happy that he decided that he could do this with us. He is a hydrologist with the USGS. Um, and we are really going to delve into this whole topic of river gauging. Um, so I think everybody is here because they're very curious about lots of different aspects, and we're going to have time for everybody to get their questions answered. Adam is going to give a talk. He's going to take questions during the talk. And I guess what works the best on Zoom is to do it through chat. So Teresa and I will be looking at the chat all the time and then asking questions from the chat or posing questions to Adam from the chat. So please enter your questions in the chat, and if and I'm sure we'll see them. So don't have any fear that we won't get to them. Adam will start, and later on in the hour or so that we hope to spend doing this, I'd also like to bring Pat Welch into the discussion. And Pat, as you know, created and maintains the Oregon River Levels site, and most of us use that. And I'm sure that Pat, having worked with, putting river gauges into that site for such a long time, might have some thoughts also about, how we use river gauges, how accurate they are or inaccurate they may be at any given time. What are some of the variables? And anyway, anything that Pat would like to add, especially maybe on how he does his calculations or estimates on the rivers that don't have gauges, that would be really interesting to hear about as well. So I'd like to get started then by I'm not going to really do a bio of Adam. I'm going to have him talk a little bit about his own work experience and his interest in the topic, and we'll just get started there. And yeah, let's get it going. Adam.
Thanks, Will. And like Will mentioned, please feel free to interrupt via chat or whatever method. I prefer a dialogue as opposed to just me talking to people for a half hour straight. So please do feel free to do that. As Will mentioned, my name is Adam Stonewall. I've been with the USGS Oregon Water Science Center since 2001. My background is in hydrology with a master's in forest hydrology, and then I started here in the survey as a hydrologic technician, which is a person who goes out and makes all these measurements and works the records up and does a lot of that detail. And I've migrated since then to a hydrologist role, and right now I'm the surface water specialist. So I kind of oversee a lot of the program development, which are studies that kind of utilize those data more than the people that actually manifest those data. So I'll get into a bunch of topics here, mostly around stream gauging. Will sent me a great list of questions, so I tried to address all those through these slides, but I'm sure I'll miss some questions. So like I said, feel free to interject. So let's get moving here, if this will work. You'll see a lot of kind of disclaimer notes. Just be aware that's just officially government USGS, mandatory disclaimers. So the data are fine, but I have to put that on there as an official thing. So just so you're not confused about why you see all this preliminary information stuff in the corner. Here's a brief outline of what I was going to talk about today. A little bit of history, talking about our gauging stations, how those operate, how we maintain them, things like that. Talk about the discharge measurements, which are what we use for the rating curves, in addition to the stage. I'll talk about our general operations, why these stations exist, who uses those data, who funds them. And then I'll get into more of the flow forecasting. I'm not an expert in that, but I know a little bit, so I'll try to answer those questions. And then some questions about the future of stream gauging and also climate change. So this is kind of a little bit of the Wayback Machine, but the earliest stream gaugers that I know of, at least, were the ancient Egyptians. They had this thing called the Nileometer, where they actually had these amazing structures that would distill the water of the Nile, and they'd go way upstream and read these. This is 5,000 years ago. The priests would go in there. They would forecast the flood season, and they would assess taxes using these levels. So this is just a brief. You probably didn't know this slide about the history of how long we've been measuring rivers and how long we've been interested in how high they've been or how much water is coming through. So getting closer to home, we've been collecting hydrology data in Oregon that I know of since at least 1858. So that predates statehood. This is a picture from the Columbia River at the Dalles, where we have data back that far. The USGS wasn't around until I think 1879. So this predates our organization as well, but we still utilize those data and have those records in a file in a warehouse, like these old paper records from over 100 years ago. So a lot of history there. So as you can imagine, we've had many years to kind of cultivate this science. It seems kind of new in a lot of ways, and obviously with technology, a lot of it is new, but there's a lot of history that goes into this and a lot of kind of trial and error and things of ways of making this work have been kind of done throughout the different decades or even centuries, really. So moving on to the basics, you may have seen different gauges around the state. I assume people are on these watercrafts and you probably float by one once in a while. Maybe you see one, driving to a site. I'll start with the older style and move to the more modern style, but the really old style that go back to the 1800s really are these, we call them a stilling well. Can you see my arrow on the, okay, excellent.
Yes, sure can.
Great. So the idea here is that there's a connection, usually two intake pipes that connect the river or stream to the stilling well. So if you imagine, the water can be pretty fast, obviously, in the Thalweg or in the stream, but once it gets through these pipes, it really slows down, and you have this nice mellow level here. And we have what we call a shaft encoder. I'm going to bring a picture of that up. It's just this giant float that floats here in the stilling well with a counterbalance, and you have basically this little instrument here that keeps track of how much this moves up and down just by the rotation of the wheel. It's pretty simple. If you go back to the very olden days, and there were still a few of these when I started around, but it wasn't even electronic. It was done with springs and timers, and there was like a little pencil trace, and you had to actually run these traces through these. Anyway, it's amazing what they thought of before they had the electronics to do this. So that's why we have those records from way back when. I'm not sure how far back those go, but they're pretty old technology because it wasn't electronics. Now, of course, it's all computerized. It's a lot easier, but we're kind of moving away from these stilling wells. As great as they are, they're expensive to make. I mean, you can imagine pouring all this concrete isn't easy. A lot of these are public works projects back in the day. There's a danger aspect. These get mucked up with sediment. You have to go in there and kind of muck it out. We've actually had one death from someone who went in there and they were trying to run the generator, and the smoke wasn't leaving well enough, so it wasn't ventilated. So we're trying to get away from those now. You'll see fewer of them, but it's a great approach to stream gauging when we still have those. What you see now more is the pressure transducer. So the idea here is it sends out a little bubble of nitrogen gas, and it measures how much force it takes to push that little bubble out. And by that, it can tell how much water is above that little orifice where it's pushing that out. So we basically run a conduit to somewhere in the stream where it's going to be, underwater all year round, even during the driest years. And Ideally, it'll always be wet, and we can tell exactly how much water is above that fixed point. The problem there is, that fixed point may get hit by a giant boulder, moved around. There's little things that can go wrong. Sometimes really high velocities can influence that too, but in general, it's a great system. And I also included this little radar unit. This is more of a newer technology that's been around, I don't know, the past 20, 25 years maybe. And it literally will sit above the water and shoot downwards and measure the water level that way. I think the technology's gotten better since I've operated these myself. I'm not sure if it's quite up to speed with the pressure transducer, but being out of the water has a lot of advantages, right? People don't have to get in the water to service it necessarily. You can stay dry, and you don't have things hitting it because anything in the water can be hit by logs or boulders, as you know, during storms. So any questions about the general idea of a gauging station and how those kind of play out? Nothing in the
I
chat?
guess I'm just curious about the relative numbers of all these different kinds that are actually in use.
Yeah, I don't have a firm
A
number.
sense of it.
Yeah, I would say there's probably, the radar is the rarest. Probably a handful in the state.
Yeah.
The nitrogen bubblers are probably 2/3, somewhere around there, maybe even 3/4. And then the rest are the old stilling wells
Are
still.
the old ones that are still working. Yeah.
Yep.
Cool. Thank you.
Yeah. Yep. That is a random guess, but it's more or less right, hopefully. Let's see. So moving on to the discharge measurements. Like I said, this is old technology. I've been doing this for a long time. But the idea is we go to these rivers and streams and we actually measure how much water is coming through. That's the second part of a rating curve. We have the actual gauging stations only measure the stage, how high the water is, but we need the second part of that, which is how much water is coming through at any given time. So let me pull up we have these meters, very old technology. And basically in the old days, you would sit there and actually count how often the meter would go around with a stopwatch, and then you would make some equations and figure out the speed that way. As technology got better, they installed little whiskers in here, so you'd wear headphones and you'd hear it. It was just easier than seeing it, and you could just have a little clicker to count them instead. The technology got better, where there was one that would count every 5 rotations if it was really fast. And then, of course, they got electronic too. So the technology kept getting better, but the basic premise is still here. It's just these kind of very well calibrated cups that can figure out how fast the water is going, determine the velocity.
And so the water speed has to be done at every location in the stream?
That's a great segue. You think I planned you here, but the very next slide kind of shows this a little bit. So what we typically do, if you imagine like a stream that's fairly low so we can weight it, I'm going to go in there and I'm going to get at least 20 to 25, hopefully 30 to 40.
How do they figure out the river levels?
I'm sorry, did someone say something or? Oh,
I muted them.
okay. So we try to get between 20 and 40 individual measurements across the creek. So this little diagram here, you see these little boxes. There should be more of them, but that's okay. So for each one of these boxes, I'm going to go in there and I'm going to measure the depth, and I'm going to measure the velocity at least one point in that vertical, maybe 2, maybe 3, depending on how deep it is and some other factors. And then I'll actually do a little equation. I'll figure out the width, how deep it is. That's my cross-sectional area of that little subsection, and then figure out the velocity. And if you know math or science, the units tell you a lot. Feet squared for area, feet per second for velocity. You multiply those two, you get feet cubed per second. So each little segment is its own feet cubed per second, or CFS. Is what we call that for short. So I'm going to go in there and measure each one of these and then add them all together, and that's my total flow, essentially. And that has been the way I think someone in Europe invented that years and years ago, centuries, but that's still the tried and true method. It's pretty simple. There's little things that have changed as far as at what depth you measure, because you want to be representative of the entire cross section, hopefully. But we have all these rules and little little methodologies for making the best measurement possible. You know,
Sure.
And-
I mean,
and-
I have a question. I mean, if you're doing, say, 40 samples in the entire cross section there,
Mhm.
you have to be making some assumptions about what's going on in between, or you have to be applying some general knowledge about the behavior of water in a stream bed.
Yep, this
So,
is true.
what kind of assumptions are you making?
So you'd be surprised. We actually account for a lot of this stuff instead. So I'm kind of fast forwarding a little bit, but you think about the stage discharge relationship. If I go in there and start my measurement and the water is at 7 feet high, but it's coming down quickly, and by the end it's say 6.9 feet, I'll prorate that in based on the measurement, based on every individual little subsection I made. So, you know, I'll say that for this, you know, 10 minutes, it was approximately this CFS or this gauge height. And so it's kind of prorated in essentially. So a lot of the time, it really won't change that much during the course of a half hour to a 2-hour measurement. If you look at our hydrographs, they're pretty stable in the summer, especially, but especially during a storm, it can change wildly. And so you really have to kind of, you know, note, and this is all electronic, but you have to note every minute what's going on there with the gauge height and the discharge. Does that kind of answer your question?
Sorry, I was muted. I don't really understand about the prorating. So no, it didn't really light up my brain.
Let me try again when I get to the rating section, which is pretty close to here.
Okay, thanks.
Maybe it'll make more sense then.
All right, thanks.
Sure.
So just a question or a comment about
Mhm.
calculating the area of the subsection. You'd get a really clean reading if it were dropping over a weir and you just had a nice straight line and it's all rectangular. You could be really accurate if you're doing that, right?
And that is 100% true. When we measure at weirs or flumes or things like that, we have a lot more confidence in our measurements in general. There are some exceptions because, how to put this? Imagine the same cross section you see here, but at a weir, it's going to be a lot lower depth, right? And a lot higher velocity, just the nature of the weir. So the little bits of error you might get in the depth will be magnified because it's such a small depth. Whereas if you have like 4 feet of depth, if you're off by a tenth of a foot, it's not really a big deal. So in general, that's true, but there are kind of exceptions to that. And as a hydrographer, which is what we call people that make these measurements, you go out there and you get a pretty good feel for where it's good to measure the river. You realize that it's better to measure here than it is 20 feet upstream because of X, Y, or Z conditions. And we're looking for those nice, almost weird, like these very trapezoidal straight reaches where the velocity doesn't change much across the cross section. Those are worth their weight in gold. And we rate them accordingly. We sit there and we say we think this is a really good measurement, plus or minus 5%, or we say this one's terrible because of these bad conditions, plus or minus 10%, 12%, whatever. So we qualitatively try to quantify the error as we make these measurements, if that makes sense. And because you have a lot of experience measuring these, you get fairly good at that over the years, I would say.
Adam, we have a question about the depth that you're taking the flow, the velocity measurement.
Mhm.
Doesn't it vary surface, middle, bottom? And how do you take that into account?
So remember, we're taking a depth at each one of these little subsections. So
What? It was all written on the kitchen counter. Wipe some dishes.
Just a minute, we'll get some people muted.
no worries.
Unmuted.
So yeah, if you can imagine each little cross section, I mean, it depends on the river width, but typically they're going to be between a half a foot to 3 feet wide, something like that. You tend to not see a ton of variation in that little, 2 foot cross sub cross section. It's usually pretty accurate. But even if it's not, here's a good example. I mean, the average depth here at this little spot here is pretty close to what you'd see if you integrated this whole thing out. So unless there's something very strange going on, it's usually a pretty good approximation of those areas.
Okay. We have a more complicated question from Horst, but I think I'm going to save that until later.
Okay, just let me know. So the technology has gotten better, as you might imagine. In the old days, when I first started, I would have that meter you saw before attached to this, what we call a wading rod, which is actually a pretty neat instrument. It's graduated, so there's little marks on the rod that tell you how deep the water is, and then you use those marks to set it up here by your hand, and it's a fascinating mechanism where if you set the same mark here as what you see down there, it'll be exactly 6/10 deep, which is what we think of as the average velocity for the profile for most streams. But now the technology's improved, so we have these Doppler instruments instead. And they actually, it's hard to see. I should have gotten a more close-up picture, but there's little prongs here on either side, like my fingers, and they both send out little acoustic signals and meet a little cubic 1 centimeter out from where those little prongs are. So it kind of, the water's flowing towards the hydrographer here. If he was better, he'd be more to the side, so he doesn't influence the flow as much, but I'm not going to judge him. That's just the picture I have. But so it'll measure that little point of water right there, just past those prongs where they would meet, if you could imagine them completing that little square, so to speak. On the right here, you'll see a more traditional, what we call ADCP, acoustic Doppler profiler. And the nice thing about these is they float on the water. You don't have to actually worry about depth, and they integrate the velocity from almost the very top of the water surface to almost the bed. So let me bring on the next picture here. This is, we started using these in I think the earlier mid 80s, when the technology was pretty rudimentary, but it's really improved over the years. But you can kind of see this boat will travel along and have one of those Doppler profilers attached to the boat and sends these various beams out, and it can actually get the velocity pretty much all up and down that profile. So back when we first started using this technology, it was just for the large rivers, the Columbias and the Willamettes, maybe, you know, the Middle Fork Willamette or Santiam on a really big flood. But now we use these, that they get much smaller now and much less expensive than they used to be. And we can use them for pretty medium to even small size rivers, which is a big advantage. There are some advantages of the old style meters still, so we don't, you know, get rid of those completely, but when we can use this, we typically do. So that's made our measurements a lot more accurate, probably. Although, to be fair, we've compared the Doppler with the old style. They're actually pretty close. I was surprised how good the old style were with this new technology.
Well, Adam, you just addressed Horst's question.
Oh, okay.
So no need to ask later.
Excellent.
Thanks.
So any questions about the Doppler tech? I know it's a lot to cover. I don't want to get too into the Doppler, but any other questions about that are posted, or?
No.
Well, I have to say, I'm looking at this photograph and it looks like the boat is just downstream from a terrible low-head dam.
A lot of these photos are lifted from different US publications from the USGS. I have no, oh, it says it right here, actually, Cairo, Illinois. Yep.
Yeah, and you wouldn't really be measuring your river there.
Yeah, I'm not sure what's going on in this picture, to be honest with you. But it's a giant river system, so I don't know, maybe this makes sense for some reason, or maybe it's just the picture they had on hand. But
it's just the picture they had. Yeah.
I don't know. Oh, but yeah, down here in the bottom right, you can kind of see how this plays out when you, you know, in this case, they're actually doing multiple transects and getting all kinds of information from the profiler, including temperature, which is a nice.
Temperature. And what's that say on the right? Backscatter? Backscatter.
So that is how much reflection the Doppler kind of gets, the acoustic Doppler. It's nice because we try to measure sediment sometimes, and you can use backscatter as a proxy for that. So but this is probably just to make sure they had a good enough signal in this case.
Okay, cool. Thanks.
So moving on to what we call a rating curve or stage discharge rating. This is kind of what you're probably interested in. And I'll try to explain this a little better than I did before, but the basic premise is we have pretty much continuous stage measurements, right? We have those gauging stations out there, and they're measuring the water level every 15 minutes, usually, sometimes as low as 5 minutes, but whatever frequency it might be. But of course, there's no one out there measuring the discharge every 15 minutes. That's not really possible. So we go out there usually every 2 months, sometimes every 6 weeks. It just depends on the gauge and the needs. And then we also go out there during big events and stuff like that too. So it's not always prescribed by the date. Sometimes it's a circumstance instead. But the idea here is that we want to establish this curve. We know all the stages. We want to see what the discharge is for each one of those stages and make this plot accordingly. This is a very, for the audience plot, right? It's usually a lot more messy than this, which is why I have this next slide. This is what it really looks like in real life. Ideally you'll go there and it'll hit this blue line, which is our rating curve here, but oftentimes it'll be a little bit lower or a little bit higher. And as a hydrographer, it's your job to kind of deduce why that is, like what happened here. Is my measurement bad? Is it something that happened at the actual site? And usually it's the site, but not always. Sometimes it's the measurement. So our protocol here is, if I go out here and I make a measurement and it's right on the rating curve and I feel good about everything, then I'm kind of done for the day as far as the field work at that site. We think it's a good measurement. But if it's not, if it's say down here, then I'm going to measure it again and check my equipment, make sure everything's working correctly. And if it still measures down there, then I know something's changed, right? So this is kind of hard to visualize. So I brought in a little extra picture to help talk about hydraulic control. So the idea here is that stage discharge relationship is driven by what's going on in the channel. So let me go back just for a minute here. This picture I took is of a beaver dam on the Nehalem River around Vernonia in 2002. So I went there and I made my measurement. I knew it was a good measurement. It's a good measurement site. But when I looked at the rating plot, it was plotting up here, not near the actual rating curve. And I thought, oh, what's going on? So I measured it again, and sure enough, it was still plotting up there. So I knew something was going on, but the channel looked pretty normal to me. So I started walking downstream, and that's where I saw that beaver dam, which was elevating the water about 2 feet. So I know I'm going back and forth a lot here, but this is kind of important to understand. So if you imagine, say I was here at about 100 CFS, cubic feet per second, and those beavers come in and raise the water level by 2 feet, my new dot is going to be 2 feet higher here, right? So that's why that's plotting off, because what the beavers did was affect that control of the hydrology, of the hydraulics. So it could have been a number of things. We could have had a big flood that happened, and where there used to be like a little cobble riffle or something there that kind of acted as control, that could have gotten scoured out, and it could have dropped the stage instead for the same amount of discharge. So that's kind of the crux of what we do, is we play detective. If things are still as suspected, then we go, okay, there's nothing to see here. But if something's happened, then it's our job to figure out what did happen, when did it happen, and how do we account for that with what we call our records, the discharge we actually worked up. So it doesn't help people in the real-time world, because we may not if we're out there every 2 months, we may not find that change right away, right? Maybe something happened with a beaver dam or a scour event or a fill event, and then we'll find it 2 weeks or 2 months later, and then we'll fix it. But that's kind of the crux of what we do. Any questions on that? That's a lot to take in, I know. So there may be a chat or two, I would imagine.
Well, something that's happened to me twice in recent times is going to the river at a CFS that was familiar, very familiar, and having the river be radically different. And in both cases, the river was lower than I expected for the gauge reading that I got online. And the change happened all at once. like there was a day when it changed.
Mhm.
And so is that because someone has changed the slope there on that line?
Yeah, so that's a very good example. So if that beaver example, right?
Yeah.
I found that problem, and I go back to the office maybe the next day or the next. Actually, we're better at this now. We used to do it the next week, but now we do it the same day because of technology. We can do it over the phone from our hotels and all that stuff. But you're correct. We will actually draw a new line that will merge with the main rating somewhere, and we'll implement that, and it will change often all at once. It will affect data back to a certain point. So that's probably what happened to you, is my guess, is someone actually made the measurement. It had been 6 to 8 weeks, and then they pushed that through the system, and that changed the discharge on the engagement side.
And so those, why would on the whitewater section, what kind of adjustment would cause that? Like, I'm just wondering, like, what part of the river changed? Because the part that we're on is not changing that much.
Right. So if
Yeah.
we keep in mind that our gauging stations are not, they're suited where what we call the control is hopefully the most stable, right? That's what we try to do. We try to find a spot where we think it's not going to change much over time, but they always change. I mean, except for some rare exceptions. Cobble and gravel get washed in, they deposit and they change it that way, or they get scoured out, and it can be the exact same site, but from one time to the next that happens. So all I can discuss is our individual gauges. I don't know how they relate to the whitewater sections themselves, because
Okay, Tillamook. Wilson Tillamook.
Okay,
it's
so
at the bottom of the drainage, right? It's down
right
by the ocean.
Yeah.
Right. We're paddling 20, 30 miles upstream.
Right. The Wilson is one of my favorite ones to measure, actually. It's a great
Excellent.
measurement section. It's so good. Anyway, that's a whole different story. But it is a dynamic system, though. I mean, I don't know if you know where our gauge is there off of highway.
Yes.
Okay. But if you go there, 1 year, then go there the next year, and if you take a picture, you will see oftentimes, if there's a big enough flood that's come through, the cobble's moved around, the riffle's not where it used to be, and that affects our rating curve here, how we establish that. There can also be user error. I mean, I know there's been at least a few cases that I've seen over the years where someone thought they had a good measurement and they measured it twice, but then they found out later on that the instrument wasn't working correctly or something along those lines. And then that manifests oftentimes way down the road, because it's not until we're doing like our final QA/QC checks where we compare the Wilson with the Trask or the Nehalem and say, well, what's going on here? Usually there's more water in the Nehalem, but for some reason in May we had more in the Wilson. That doesn't make any sense. And then we start digging into stuff. So it's, we try to be as real-time efficient as we can, but oftentimes we find things, down the road as opposed to right away. Having said that, we're getting better with the technology and utilizing that. So I think hopefully you're seeing fewer of those instances than you did in the past.
Just two in my whole time here, and it's just been in the last couple months.
Oh,
Malala is the other one, can be.
Okay, well, that's interesting. Yeah,
they both seem different.
And I don't know what the cause of those individual cases were. I can only speculate, but
and abruptly different.
Yeah. And you can also have equipment failure too. I didn't mention that as another option, but if people vandalize our stuff, which happens sometimes, like that nitrogen bubbler I talked about, right? That's in a pipe at the end of in the river. If someone comes by, and you'd be amazed at what vandals are capable of doing with the time and enthusiasm they have sometimes. They will like break that apart with a rock or a pipe wrench or something, and all of a sudden it's dangling in the water instead of being in a fixed point. And now we don't know it's bad, but we're getting bad data. Those kind of things happen too, unfortunately. But we're getting better at trying to keep those more vandal proof. It's just hard sometimes. So,
yeah.
So
Adam, we have
you can also
question.
get,
Oops,
or
go
can
ahead.
you get deviation from the mean there if there's upstream tribs, maybe being locked up by freezing temperatures that might cause depressed measurements, or maybe a microburst upstream on a particular trib, and you get localized heavy precipitation, and that might, give you a data point above that mean. Is that the case?
So we're getting kind of into the future part of the presentation, which is fine, but no, it's all good though. But I think where we're going with this is there are national models being developed. They're going to predict stream flow for every stream in Oregon 100% of the time. And I think what's going to happen eventually is we're going to check against those, right? Those aren't going to be that accurate, but we're going to have like a nice way of looking at that and saying, well, boy, that's not what we'd expect based on what's going on with the Trask River and then the Halem River. Why is the Wilson this high or this low or something like that? I think we're going to have more of that in the future, more utilizing just the network of the gauges plus remote sensing plus modeling to actually find those errors more quickly, hopefully.
Adam, we had a question about when you make that adjustment in the rating, how far back do you go, and what are the criteria which determines how far back you go?
Yep. Let me go to this other one here. That's a good question, and this could be a long answer, but I'll try to keep it short. So the answer is it depends. If there's a giant event that happened, and especially if it's a scour, what we'll probably do is, imagine this rating here. This is Quartzville Creek in the Santiam system, the South Santiam. Imagine that we had this rating for a while up on top and this lower rating, right? So let's say that it's been this rating for a long time, and I show up one day and all of a sudden it's down here. What if there was a giant event that happened, and I think that event scoured out the control, and that's why we're seeing this? What we'll do is until the event happened, stay on this old rating, and then maybe we'll tie in the new rating, say around here, and then the water keeps going up, and then when it comes back down, we start using the new rating. So essentially, the more water there is, the more stable these ratings are. I mean, they really don't change up here in the very upper part of the rating. It's just dominated by the overall channel geometry, which doesn't really change, like the overbank. The little bits of scour and fill at the bottom are just inconsequential when you're up here, at like 10 to 100 times what the normal flow is. So it's a good way to have this like nice stable part of the rating here. Then we can work around with the bottom part. If I say make this measurement and come back later and it's up here, and it's been the summer or late fall and it's been low flow and no real events, I will just prorate that between my 6 to 8 week visits. So it's not like it just goes from one to the other right away. Every day, essentially, if you could draw the new shift, it'd be a little bit moving towards that next one day by day, like a little clock ticker, and eventually it gets there. So there's a lot of proration going on between these different shifts. So it gets back to the detective work I talked about before. It's not always easy, but usually you can kind of piece together based on when do we have big events, how does the control look, what are neighboring streams doing, if Wilson's usually 185% of the Nehalem, and all of a sudden it's not. When did that change? So things like that can really help out.
Great.
Yep. Let's see. I think we're getting a little low on time. I put too many slides in probably, but
It's okay.
keep moving along. But before I do, any more questions about the rating? I know there's a lot to take in there. I want to make sure I answer all the questions because I'm moving on to a different kind of phase now.
What part of it is art?
A big part is if I have a couple of measurements here, for example, where do I connect that? And I'm trying to figure that out by the shape of the channel, where we surveyed in, kind of, there's a little bit of gut instinct sometimes, even because you've been there, you know, a million times, you kind of know the system. But I could have a different rating than the person next to me, and it's just as valid. But that's how I could think it was kind of art. It's not always exactly objective, you know. There's some subjectivity in there for sure. So
Right. So one more question, actually. Like you say in your top bullet that you measure stream flow every 6 to 8 weeks. Do you go for the higher flows or lower flows or whatever's out of the ordinary?
that's a great question. And yes, it's very, I shouldn't say easy, but it's pretty easy to get flows on most of the rating curve. These ones up here are just so rare that we prioritize those. So it's all hands on deck when there's a big event. I mean,
Yeah.
the 96 flood is a good example. People working around the clock, more or less.
Totally.
We can estimate measurements after the fact. We can go out there and get high water measurements and use some modeling techniques. It's not as good of an estimate, but it's better than no estimate. So that happens a lot too. But
Yeah. Yeah.
you know, when you got hundreds of gauges, you can't be everywhere at once when there's
Oh,
a 2-day
no,
storm.
and you know,
So,
we would
yeah.
never be there because we got to go boating then.
So I actually do have a question, and
Awesome.
it goes back to your, sorry, I was testing my mic earlier, the radar on the boats, right? And all this. I mean, gauge level is really important. Has anyone ever in the hydrology, you know, profession, do they ever map the rivers and kind of identify where the obstacles are, you know, kind of give us a nice little map of ideal lines and stuff, you know?
Yeah, that's a good question. We do we'll do some work, what we call longitudinal work. Sometimes it's not for that purpose, obviously, but I know we've experimented recently with kind of like a GoPro camera where we upload all the images and post those into like a repository of some sort. And we also collect bathymetry. So when we model a river, we need to know what that looks like on the bottom for our modeling purposes. So that could be helpful, I would imagine. But the data aren't that accessible unless you have these models to run, like unless you know how to run HEC-RAS or SQL W2 or one of these models. So, you know, I'm gonna step back from that. Actually, I take that back. We do have some products that you can find on our Sciencebase page that are what we call digital elevation models. So if you have any GIS experience, you can bring that into ArcGIS Pro or something along those lines.
Yeah, drones and ArcGIS. So that I used to do that.
So if you go into let me put this in the chat. It's USGS Sciencebase. And let me see. There we go. I don't have the URL memorized, but if you just Google that and then Google like Oregon and DEM or digital elevation map, you might be able to find some that would be helpful, actually, I would imagine.
Okay. Yeah, thank you.
Yeah. Okay, I'll try to blaze through these ones kind of quickly. You're probably aware of why we have these data, but this is one of the things we wanted to talk about was a lot of it's for designing bridges and culverts, other engineering structures. There's a lot of our data are used for dam operations, for permitting. Let's see, and then of course, water rights, one of the great pastimes of the West. It's a big deal there. As far as funding, you know, we're kind of a weird organization. So most government agencies are funded through appropriated dollars. A lot of our funding, I think more than half, is through government contracts with other government agencies. So I'm kind of this weird hybrid of scientist, salesman sometimes. I like the scientist part a lot more than the salesman part, but we actually look for work through other government agencies, and they'll come to us and say, we'd like you to, you know, measure the inflow to the Dexter Reservoir or Fern Ridge, whatever it might be. That's how a lot of our work happens. Part of it's appropriated funding, but really the meat of the efforts, especially for the study section, are through these contracts. as far as technology changes, that's something else Will asked about. I've talked about the going from mechanical to electronic and Doppler technology. You may have noticed, like I've done a pixelation effort here on this instrument. The idea being that we don't advertise private companies, but we use them all the time now. All of our old equipment, which a lot of it is still in our old warehouse that we haven't gotten rid of, or our little museum thing, it says property of USGS, was made in the government, factory or whatnot. Now it's all private industry pretty much, with some rare exceptions. So that's a big change for us. And I'm not sure if it's better or worse. It's just different, to be honest with you. Of course, the changes from the old steering wheel to the transducers and the remotes and the radar. Remote sensing is kind of the new frontier, using satellite or plane aerial imagery data, all kinds of stuff like that, drones. There's a lot of problems using that technology now, but it's getting easier and easier and better and better. Don't know where it's going to end up, but we're using the remote sensing for a lot of purposes already, including people are trying to actually measure discharge using satellite footage. Instead of measuring the height of the river, they measure the width using these satellite imagery. And instead of having a stage discharge, it's a width discharge. So there's problems there because width is a little more variable than height. But if you have a clear day, you can measure it anywhere pretty much, as long as you have that relationship set up. So anyway, a lot of advantages to that. We'll see where it goes with time. I'm kind of curious myself. And of course, like most places, we've kind of gone from the old pencil and paper to digital. I was going to say that the main advantage of this is now, in the olden days, you'd put a hydrographer on, give him a train ticket, send him out with like some instruments and a suitcase and his 3-piece suit. He'd come back 2 weeks later with a handful of data. Now one hydrographer can do a lot more work than one could even 20 years ago, but especially 100 years ago. So we're kind of accelerating with the technology and what we can do, which is kind of nice, but kind of overwhelming sometimes too, because the more data you have, the harder it is to kind of control the quality. So there's a push and pull there. So I'm going to move on to forecasting. Any questions on the previous slides? I've been kind of going through those pretty quickly here, I feel like.
No, you're doing great.
Okay. So I am not part of the Northwest River Forecast Center. I interact with those people to some extent, so I know a little bit about it, but I'm a little bit out of my league here. But just so people are aware, there's a River Forecast Center here in Portland. There's some other ones around the region, operated by NOAA, of course, and you probably already know the websites. There's a handful of forecasting stations. Those stations, they can't put a forecasting station everywhere there's a USGS gauge. They have to have enough time, like enough period of record, to actually be able to create a model from those data. So when you see a new gauge up, don't expect a flow forecasting spot right away. And they're also, of course, constrained by their personnel capacity. What they're working on now is the National Water Model. And that they'll still have what they call the AHAPS, the Advanced Hydrologic Prediction System, whatever it is, like you see here for Nehalem Foss. But in the future, they're going to have every stream, every creek forecasted. I think this is going to start sometime in the fall, from what I heard recently. And Portland is one of the first regional offices to implement that, actually, to implement this National Water Model on the regional scale. As far as that being on time, I can't guarantee that. That's just what they're shooting for right now. But in theory, you'll have a way to predict stream flow anywhere in the state not too long from now.
Wow.
That's exciting news.
That's kind of big, yeah.
Yeah, it won't be as accurate as the old AHAPs, I can guarantee you, but it'll be something, and I'm sure it'll get better.
I mean, where is it likely to be high accuracy or low accuracy?
Yeah, that's a good question. I would say a general rule, the bigger the system, the more likely it is to be highly accurate. I mean, there's just
Right.
more variability with the smaller creeks and stuff like that.
But I mean, what feeds into this model? They have to be going for precip and
Yep.
freezing temperatures, and what else?
Yeah, I don't know the model that well. I know precip's a big part of it. You're right about the snowpack, what's on the ground, snow water equivalent,
Yeah.
as they call it. Soil moisture is a big component. So if the soil is dry, it can absorb more water than if it's wet already. A lot of fixed things like slope and things like that. But there's things I'm probably not thinking of that are probably in the model as well. But
Yeah.
I'm kind of curious to see how well it's going to work. They've been working on this for a while, and they're rolling it out pretty soon, so they must feel good enough about it right now to do that. But
Yeah,
I'm
it's pretty
curious.
awesome.
Yeah.
But I
But
have to say that the boaters here are pretty darn good at calling it, and they beat NOAA most of the time in terms of knowing where the water's going to be, and
yeah, yeah, it'll be
So Adam,
interesting. Yeah.
I've thought in the past, in looking at a lot of these predictions, that they often go for the worst case scenario. And I wonder if their purpose is to make sure to warn people of high water events.
Yeah, well, I've had that same thought, and I've tried to pin down the forecasters on that. They won't admit to it, but I'm really sure that's true. I mean, I watch these forecasts all the time, and 9 times out of 10, I feel like they're overly forecasting a little high. And as a government agency, you hear it when you mess up, right? So my guess is that if people thought they were safe and they got flooded, there'd be hell to pay. So
right. So they err on the side of warning.
Yeah, it's probably
Yeah.
baked into that. So
Yeah.
I don't know. I don't know what to tell you. The new systems, I think they have a probability like cloud around it. So there's a 10% chance of it being higher than this and a 10% chance of being lower than that. It's like a big confidence interval. So my guess is that if you look at it long enough, you'll be able to figure out that usually it's around the 30%, like you'll have this kind of like rule of thumb to kind of go by, but who knows? We'll see how it plays out.
Mhm.
Let's see. As far as the future goes, I talked about remote sensing already. That's going to be a big thing, I feel like. The other thing I feel like is going to change is in the past, we've had kind of a one size fits all to our gauging stations, and they're not cheap. They're fairly expensive actually to run and operate, not to mention install. So I'm anticipating more kind of gauging by proxy or kind of minimalist, gauges that are cheaper to run. I think that's just going to be the future. And then with machine learning and other new approaches, we can actually you can sometimes get a better estimate having more lower quality gauges than fewer high quality gauges for the ungauged sites, if that makes sense. So I'm kind of anticipating that being the future, but we'll see how it plays out. Old habits die hard, and our bread and butter is our data quality. We really pride ourselves on that. So it's going to be hard for us to take a step back on some occasions to having more data, but lower quality.
Mhm. Cool.
And then I think the last few slides are on climate change. I know we're getting low on time here, so I won't cover this in too much detail, but people have probably seen a lot of the predictions and they change from region to region. But in the Northwest here, one thing we expect is a lot more variability in the weather, as opposed to just it getting more dry or more wet. It's supposed to be more of each, really, depending on the season.
Mhm.
So for gauging, it's not going to affect how we gauge directly, but more variability means potentially larger floods, which means more damage to our equipment, which means we have to replace those more, which is more expense. It means going out there more. The other thing that's interesting is we use a lot of these data, these historical data, sorry, to predict the future. Like when you design a culvert or a bridge, you're looking at all those data in the past and saying, we're designed for a 100-year flood or a 50-year flood, whatever it might be. Because those floods are changing quicker now, that means those data aren't as valuable as they used to be, which is an issue, because when you have 100 years of quote stationary data, you're a lot more comfortable with it than you are with 100 years of non-stationary data. Of course, there's a shift in the seasonality of what we call the hydrograph. We're expecting less snowpack, which means places that are really affected by the snowmelt, we expect there to be earlier releases. And then of course that can change how flooding happens too. So that, we're not a snowpack dominated system like some other places, like in the Midwest, but it can be a pretty big component. And to be honest, that can be a plus sometimes too. Some of our most historic floods were ones where we had a pretty big snow cover at low elevation, and then a big Pineapple Express comes in and melts it quickly, which is why we had the 96 flood or the 1861 flood or the 1964 flood. All those giant ones are pretty much very similar conditions. So, more rainfall, but less snow, maybe it'll balance out. It's hard to say, but these are being studied as we speak. And then of course we might have drier summers, more drought. As the atmosphere warms, it can hold more moisture, which can cause obviously larger floods from that end. And I already discussed the variability. I think I've got one last slide about what I call non-stationarity, and I'm going really quick here, but these are the things that I worry about making the data less useful as time goes on. Climate change being something I discussed already, but the other thing that's happening is these climate periodicities like the La Nina, known as ENSO, or the Pacific Decadal Oscillation, which is a really big one actually. It's like a 20-year cycle, 22-year cycle here in the Pacific. But also we have, regulation dams come and go. We were in the era of building dams in the 40s and 50s. Now we're kind of starting to be the era of removing dams a little bit, which is kind of interesting. And then, land use changes and urbanization obviously change hydrology, and then channel modification. And I think I have 3 minutes to go for questions. Sorry I went so long, but that is all my slides at least. Yep.
That's great, Adam. Thanks so much. We do have a couple of other questions, but before we do that, I want to jump to Pat Welch, get him in here to talk a little bit and share anything that he has to share with us. I'll give him the chance to anyway, and then we'll get back to questions. Pat, you there?
Yes. Adam covered much of it. What I do is a lot more math of how do I model up virtual gauges or understand scouring events or sedimentation events and map it through. I also look at things like, if you look at the Siletz drainage over, we have almost 100 years worth of data there. You can actually see the exponential fall off change as they log different amounts. And for the soil or the retention, I will say, ask questions and I can probably answer them, but mine is more for presentation and thinking about it from the standpoint of boating, but fishermen use it and a lot of water users consume my site. And yeah, so ask questions, please.
Pat, are the only rivers on the Oregon River level site that you estimate the flow for? I looked at it briefly today. Are the only estimates you make basically from tributaries or branches that by subtraction or subtraction, addition or subtraction of flows, you come down to what's left for that tributary? Is that the only time that you do that estimating?
No, those are the easy ones. They're like the White River coming into the chutes, which goes from about top end of the drainage is around 7,000 feet. And then you're at about 2,000 or under 2,000 at the bottom. So you have a huge variation of snow level or freezing level that you have to account for. And so that one uses the chutes and the difference of up and down, but there are enough other tributaries between various Deschutes gauges that it also factors in the Hood River gauges, the Clackamas gauges, and other things. So basically what I do is I try and figure out what the drainage looks like from various properties. For us, it's mostly elevation, but also soil types and land cover types. Collect a bunch of gauges and then run them through regression analysis. And I do what's called a stepwise analysis, where I only find I use the minimum amount of data I can to do a prediction. And then I also, if I have enough data, do out of sample type of predictions. So I'm actually doing a valid prediction versus an estimation. I mean, as Adam mentioned, there is a little more complexity of machine learning that goes into it, but so far I've not found any examples where it actually improves the data or the prediction. So it's a lot of math.
And Pat, are you predicting you're trying to predict the gauge level readings by using past data?
Yeah, so what I do not do what the national or the new national water models are going to do, which hopefully, I mean, I have some sense of what they're doing there. And when you add in SWAT, a new satellite that's up there, that will be able to get a lot better data, finer resolution. Hopefully the models over the next 5 years will vastly improve from the input data that we're getting. So for those who don't know, SWAT is going to allow us to look at water level. It's especially looking at water levels including in rivers, lakes, and it has a Doppler shift on it. So you'll be able to get velocities out of it that are a long trajectory or a long path. So there will be a huge amount of data coming in to the tune of petabytes a year. How do we interpret it? That's going to be the question. But what I end up doing is I use historical gauges to predict that have been taken out of service for various reasons. And then I try and model that up using current gauges. How well it works varies all over the place. And typically it's much worse at low flows than at higher flows. I mean, on the white, for example, that one at low flows is give or take 400 or 500 CFS at a mean of 200 CFS, but at high flows of 6,000-7,000, it's still give or take 500 or so, but fractionally, it's a much better estimation. Now, the number of you who have ever been on the white at 6,000 or 7,000 is probably 0.
Wouldn't want to.
It's pretty insanely intense. So no, I mean, it's currently I'm predicting places that have had gauges in the past. In general, there are a few exceptions to that, such as the Salmon Creek off that comes into the middle fork of the Willamette. This is a case where I have a good upstream gauge and a good two good downstream gauges with the North Fork and the Middle Fork coming in. So I'm able to give a reasonable estimate on Salmon Creek. It also comes from, I mean, a lot of the data there comes from Jim Reed, who he lives up there and has boated that so much. He's like, okay, Pat, here's what the level is today. And so it's anecdotal. It's not as good as my normal predictions, but it's better than nothing.
Understood. Thank you.
Pat, you're wearing a shirt from a paddling club. What club is that?
It's Outrigger Canoe Club in on Oahu.
I actually know that one. I used to live right near there.
For those of you who don't know, I do actually own an outrigger canoe and I paddle it occasionally.
Awesome.
Hey, I hate to be so talkative, but I do have a very basic question if I can ask it to anyone here. So I'm very new to this. You might have met me at the potluck asking random questions like, how do I get my boat on my Jeep? For the gauge reading, let's say I'm planning an event to go out paddling. What's the range I'm looking for safe enough to avoid rocks, but not so crazy that I might die. Do we have that range?
It's dependent on the river. On
Oh,
my website, I have a high, low, medium, which comes from various guidebooks. So the best thing I would say is look at a good local guidebook.
is your website linked in this chat maybe?
Somebody had it up at the top.
Okay, I'll find it. Thank you.
And Rachel, talk to other club members who might have been there at all different kinds of levels. They can tell you a lot.
Yeah, like if you want to come boat with me, you're going to be boating in the highs on all of my charts. But most people don't boat with me.
Well, Pat, I have a question. When we look at the description, how you put a virtual gauge together, or just simply what part of soggy sneakers the attribute like high, low, and so forth refers to, you are referring to the 4th edition of soggy sneakers.
Actually, the originals, when I started that database, let's see, for those of you who don't know, I started my levels website in 1995 or 4 or 5, based on an offhand conversation with Jim Reed, who is a boater down in the Springfield area, when we were trying to estimate what Salmon Creek was. And so that was the origin of my website. And at that point, I had the entire digital version of Soggy Sneakers 3rd edition. We have updated many of the things to the 4th edition, but not to the 5th. So yes, it is dated. If somebody wants to pour hours of time into it, ask me and I'll tell you how to do it.
Well, actually, you do have an option to input a suggestion. How is that processed? I've never did it. And maybe I have done it once. I contacted you, and I think. Yeah.
I actually don't know that it still works, but so I wrote the entire set of software suite there starting in 94, and it's gone through at least 3 evolutions. And it talks to a backend database. So when you are inputting data, it is running various scripts that input to my databases directly in a staged area. I've had people abuse it. So this is why I'm not sure it still works, and why it asks you for a lot of authentication methods to make sure that people aren't just hacking it. So yeah, I mean, there are methods. Whether they actually work or not now, I haven't checked recently.
Thanks.
All right.
I give it a try after the talk. You bet.
It seems to me there's a bunch of questions back there for Adam that we never got to. And I wondered if anybody in the audience still wanted to ask any of those questions that we didn't get out.
I got a quick one. Probably simple, I would think. I paddled in different countries in the world, and especially like Europe, they use cubic meters per second versus cubic feet per second.
Yeah.
I just wondered if Adam had an opinion on if you were king for the day, would you use feet or meters worldwide and make that a mandate worldwide? What's scientifically, what's your opinion on what do you have an opinion on what's better?
I love this hypothetical where I'm king somehow. We have to decree all hydrology all over the world. Cubic meters makes more sense. I'm used to cubic feet because I've dealt with it my whole career. And once in a while, I'll review a paper where it's in cubic meters. I'll be like, what? Okay, where's my calculator? So I'm used to feet, but you know, the metric system's it's just a better system, to be honest with you. So yeah.
Yeah.
And I actually convert all of the units that I get into metric, and then for human presentation, put it back to English.
Put it back in CFS.
Yeah. I mean, it's easier to do the math. I mean, it's not easier, it's just a translation. But for me, is because I am also a scientist and it's just what I deal with.
I have a question about how to interpret looking at a hydrograph. My understanding, and I don't know that this is true, but my understanding is that if you calculate the area beneath both the climbing and the recessional limb of the hydrograph, you calculate that area and square it, that'll give you discharge.
That doesn't sound right. If you calculate the area, you will get the cubic feet. You will get the volume. I don't
No, you
think-
get square feet, and then you need the flow to get cubic feet.
No, you actually get cubic feet because the hydrograph is in cubic feet per second.
Oh, right.
You're taking that area and multiplying it by the time, you know. So, but yeah, I'm not sure where the squaring part came from.
I may be hearing that wrong.
Yeah.
But
I have a
that
question.
would give you discharge though over.
It would give you
over-
volume. So the discharge is like the hydrograph is discharge. You know, it'll say
Right.
10 cubic feet per second. But yeah, if you took that whole area and multiplied it by the time, that would give you volume. Cubic feet, not per second, just cubic feet. If that's something you want, but I'm not sure it would be very handy for your purposes, probably.
I want to ask you something I'm really concerned about. For a couple of years now, I go to the USGS website, and I'm landing. I go to my old links. I get redirected to the so-called next generation web page, which is really handy and nice for cell phones. And if you want to have a touch screen and want to figure a few things out, but for serious work, for documenting an issue or so forth, it's not very useful. I cannot save a graph. I can only take a snapshot, which is device and browser dependent. And I'm reading that the so-called legacy part of the page will be disabandoned, and that totally scares me. That's such a useful tool, and I would like to hear that that is not the case, that we will have that available for some serious work.
Yeah, you really struck a nerve there. I relish the old legacy system. You're absolutely right. It's the new one's great for your iPhone or whatnot, for a quick check. My suggestion to you is please write in to the comment section there. Like, they actually do listen to those, and I've made my comments just pretty much what you just said, to be honest with you, pretty identical, but the public comments matter more to them than mine do, believe it or not. So more people that write in, the better. And I think what's going to happen is you'll probably see they'll get rid of before they get rid of the legacy one, they'll implement some of that functionality to parts of the new next generation. But until we kind of harp on them, they have to integrate that other stuff somehow in a way that still makes it very user friendly, and we just need to push them. That's the only answer to get all that functionality back.
Well, since I have you here, one of the two things that are really important to me is to save a graph as it is, independent of my device. And the other things is having the stage and the flow or the discharge parallel in a numerical output. I take a snapshot of it, and if I have a discussion with someone, I can always show that as a real fact. I don't have to touch the data in a way that may that is prone to errors. So that's very valuable to have them in one record.
I'm going to put this in the chat, but there's also a tool we have that's not very well known about called Datagrapher. So I'm just going to put in what I would do to search for this in Google, Datagrapher USGS Oregon. That is an amazing tool for what you're describing. And that's not going to go away. The person that manages it has retired, so it may get antiquated, but it's a great tool for what you're describing there. To be able to, you can it's got so much functionality. I don't want to get into it right now. It's a long, the whole other presentation, but I'd recommend seeking that tool out, and feel free to contact me if you need any help with it.
Great.
Of course, the other place that since the USGS interactive stuff is changing, so I use their API, but the Northwest River Forecast Centers makes a lot of the USGS data easily available as tables.
Good to know. Thank you. By the way, how do you spell gauge?
If you're with the USGS, you don't use the U. That's something they decided back in 1880 or whatever, and we've stuck with it. We have this style manual you wouldn't believe where we can't use etc. We can't. It's very prescriptive, so that's an interesting one.
Well,
Well,
I've gotten that too, and if you go to the Webster dictionary, they're equivalent. You can use them interchangeably, but different style guides are different.
we might be getting down to the end, you guys. I really appreciate and want to acknowledge both the presenters, both Pat and Adam. Thanks so much, you guys, for doing this for us. I learned a ton.
I actually have a question for you. If an organization wants to sponsor a gauge, how do they start this? This actually comes from a question Horst mentioned that one of our local gauges in the Mid-Valley area is apparently scheduled to be decommissioned.
Mm-hmm.
And there was a question of could a local organization sponsor it or not?
Yeah. Actually, you can contact me directly, but I will put you in touch with a fellow named Mark Stewart, M-A-R-C, not K, Stewart. He is our data chief, and he's the one that kind of oversees that program. So, we usually cooperate with various government agencies. I've heard of private groups being contracted with rarely, but it's not unheard of. So I wouldn't say it'll never happen, but I just don't know how that would play out. They're expensive, so be warned. They're not cheap to maintain.
Butte Creek.
Abaquah.
Yeah, which one are they thinking about?
The Abaquah was discontinued for some reason. Yeah, Adam, why is a gauge sometimes discontinued?
Yeah, so sometimes it's just part of a study. So we want, a good example is there's this little creek called Zollner Creek, and we had a 20 or 30-year water quality study that incorporated discharge from that. Once the study ran out, the money ran out, and that one went away. I know there's a gauge on the Rogue River that's next in line to be cut. The Marys River by Corvallis is on the chopping block, supposedly. We have what we call FSP. It's a Federal Priority Stream Gauge program. So we can allocate some money to some gauges to keep them going sometimes, but that's limited funding. So usually what happens is either a cooperator wants the gauge for a while, then they decide they don't need it anymore, and they just pull the funding, or it's a short-term project. Those are the two main reasons they get axed.
Adam, I have another question. Not just, well, on the opposite side of why are some gauges discontinued, why are some gauges there? For instance, the Upper Malala, like up near the Table Rock Fork, even above that, I think, is a gauge, just above that is a gauge. I got the number here. I found it just a few weeks ago. Was so surprised because we were always bemoaning that the gauge that we use to run the Malala whitewater sections, the gauge is so far, it's down at Canby from that.
Yeah.
And it was never really a good correlation of what was going on up on the Upper Malala.
Yeah.
So there's this gauge on this little tributary that comes in, or maybe it's the main stem that comes in above Table Rock Fork, and it has just a few CFS. And I'm wondering what's the utility of that kind of a method?
Is that Bull Creek?
Yes.
Yeah.
Yeah. So the Bureau of Land Management, they're in charge of, maintaining their lands, obviously. And what they do is, this is actually great because a lot of our stream agent is biased towards larger creeks and rivers, but we want to know what's happening in smaller creeks too. I mean, you're going to see climate change manifest there. It affects all kinds of modeling. So we actually have a dearth of smaller creeks. And the BLM is one of our partners that actually cares about that because of their own land conservation efforts. So we have one called Bull Creek, we have one called Schaefer Creek in the Cascade foothills, and the Tucker Creek in the coastal range. All those are ones that you'll see that are oftentimes below 1 CFS in the summer, below 10 CFS most of the year. That's just a science question. It's just, how can we better predict stream flow across the region? We need those small creeks too to be able to, make the national water model better, for example. If we only had large creeks, it'd be hard to predict the smaller ones. So that's part of that equation.
Yeah, I get it.
I have another one. Is there a way of looking at historic rating tables? If you want to go back, I found the one that is current, and I still had a question in the chat. How to interpret it. There's a little bit of a terminology that I somehow can second guess, but I would like to be sure. So you did have a reference to a more scientific number of pages in there. Maybe I find it there. But as far as the Molala discussion and the recent change in the rating table is concerned, I would love to go back and see what it was before. Is it an effect that the measurement was done at 4,000 and we were debating around at 1,000 CFS on the Canby gauge? And sometimes I wonder if the fit is actually, if that's accurate, if that changes. And I think it's a multi-part question. One is, do us little people get access to the historic rating tables? And the other one is, you never mentioned the parameters that are used in the fit. You always, on USGS on the website, I don't see them. I find them on Wikipedia, like the 3 parameters, the exponential, the zero shift, and the scaling. But I don't find that on USGS, and I don't find those parameters in the rating table. Are you guys adjusting those too once in a while?
Yeah, so
the exponential, the curvature actually gets tweaked.
Right. So there's quite a few things there. Let me start with the parameters, because I think you might be conflating the flood frequency analysis with the rating curves. So we use those parameters for our flood frequency analysis, which has all the skewness and all that stuff. That's a little different beast. That's how we estimate 100-year floods and things like that. So
no, I didn't mean that. Yeah.
Okay, because we don't use parameters for the rating curves at all. They're pretty much hand drawn.
Oh, really?
Yeah, in the old days, we actually had plastic or wooden curves of all different shapes and sizes, and you try to fit the line and everything. Now, of course, it's electronic, and we have all these rules and stuff. So you wouldn't see any parameters in our rating curves. So I'm not sure what you were, but as far as the older rating curves being available, I was trying to keep things simple for terminology, but we have rating curves and we have shifts. So we'll think of a shift as like a temporary rating curve where we had a measurement or two and something happened and we shift to there and then we shift back. So the rating curve is this permanent fixture and we draw shifts around it back and forth. And we only make a new rating curve usually when something dramatic has happened and we've had shifts for a long time in the same direction. So you can go back and find old rating curves, and there's some subjectivity as to when you make a new rating curve, when it's warranted. But it's probably not going to answer the question you have, where every individual shift and why was this drawn this way or whatnot. We do have they used to be annual. Now they're more sporadic because we're not fixed on the water year like we used to be. We have these little write-ups where we'll say, here's what we did this year. Here's how that shift was drawn. Here's why we did it. Like it's a very small narrative. I think as you go back further in time, the narratives weren't very good. They were just like, we did this, and you know, you don't need to know why. Now we try to justify it a little more. But if it's something you really want to know, you could do a Freedom of Information Act or just contact us in general. We'd probably provide that. I think the old ratings are available if you know where to dig, but they're hard for even me to find. But they are out there. Yeah. Long-winded answer. Sorry about that. But yeah.
Really great.
Typically, I end up, well, they're for different gauges, they're different. USGS, if you go to the site information, you can dig into it and dig them up. If you want like the Corps of Engineers, those are an FTP site that they make available. And if you go to eWeb, some of their gauges I've only ever found the current ones. The Bureau of Reclamation makes different ones. So they're all over the map in terms of availability.
Oh, here's another one. You talked about stream gauges. A couple of us are actually interested in the inflow at reservoirs. And they're interesting because they have the prediction. It's a NOAA sites. So on the Raw River, on Fall Creek, in the Upper Willamette Valley. The question was, how is it actually measured? When I look at the location on the map, they are sitting somewhere near the gate, like where the lock is. Is that actually measured by looking at the water level in the reservoir?
Yeah, we have these gauges. Actually, the USGS operates a lot of these, and they're kind of, I don't want to use the term MacGyvered, but the dams weren't made for us to gauge them, so we have to kind of find a way to do it, and we'll often find creative ways in forebays or whatever. So yeah, that's how we tend to measure those, and of course the input. You know, we usually have some tribs that we measure and some we don't, but the Corps knows the bathymetry of the lake. They know how much they allow downstream, so they can kind of figure out the total input, and they have their own webpage where they actually show the ins and outs from the reservoir. So yeah.
Well, you know, I'm thinking we got to let Adam get home. Thanks for sticking around so long. I do appreciate it. All of us do.
It's good timing. The cleaning crew just arrived, so I think I'm gonna head out. Yep.
Get out of here. Yeah, I really appreciate you. Thanks so much, both of you. It's good hearing from Pat too. Yeah.
Yeah. Thanks, Pat. Thanks everyone for joining. And this will be recorded. You can tell your friends if they want to catch it and they weren't able to make it, they can catch it on the YouTube channel that the club has.
That's awesome. How about the